I'm Gareth with Nanometer, and this is Ask Nanometer, your technical questions answered in plain English. And today's technical question is, how does a tunable fixture work? Tunable, dynamic, whatever you want to call it, we have two LEDs, warm and cool, and we're using them to mix a color temperature of our choosing. But what are the major considerations? As how a fixture is to be controlled is generally out of a lighting manufacturer's hands, most manufacturers publish the output and wattage for both chips on full. So if a spec sheet tells you that a tunable fixture is comprised of a 2700K and a 4000K chip and it's 5 watts per foot, that's 5 watts per foot when the channel is playing both channels on full, which would be a CCT of around 3500K. This is going to mean that with only one channel on, let's say that we're going to use the 2700K chip, the power consumption is only going to be about 2.5 watts per foot. Of course, this reduced power consumption is also going to mean that we have half the amount of light. So the next question is, how do you maintain the brightness on a tunable product? This question actually has a few different answers and is dependent on how the fixture is going to be controlled. If we're using DMX, it'll be up to the person programming the control system to make sure an appropriate level of intensity is chosen for each CTT. Remember, if we want to have one channel on full, say that 2700K, it's going to be a lot less bright than if we were to put both chips on full blast. So the program is going to have to make sure that they adjust the levels appropriately so that the brightness level is maintained across the bands of CCT. Those values are also going to be dependent on the chips used and the dimming curve of the DMX decoder. Remember, with a logarithmic dimming curve, as the DMX value increases, it will allow more power to flow to each channel in each incremental step. With a linear dimming curve, you'll have an equal incremental addition of power with each step. If the fixture is going to be controlled by two 0 to 10 volt dimmers, the process is a little simpler. As we know that 0 to 10 volt is basic by nature, Nanometer has gone to the trouble of designing a dimming interface, our DM10X, that will manage the intensity as the CCT is shifted from warm to cool. In this case, we limit the power draw at the neutral setting, or both channels on full, to be only 50% of the potential brightness. This will allow the intensity to be maintained across the color range as you adjust with that single 0 to 10 volt dimmer. Let's take a look at this on the bench to see how it looks in real life. Well, here we are in the boneyard, and I've got a nice little example for us with a Nanotech 1x1 fixture and the DM10X interface. So the first configuration we're going to do is with a DMX signal. I've got it connected up to a multimeter here so you can see what you're doing. And basically on the DMX sliders right here, you can see that if I bring in all of the cool chip that's on right now, and then I bring in all of the warm chip, you can see it's nice and bright, and the power consumption for it in this configuration is 14.7, around 15-ish watts, right? Now, as I remove some of the warm component, and actually remove all of the warm component, now you can see that the wattage is now gone down to 7.5 watts. So what is this telling us? It's basically telling us that each chip is responsible for half of the wattage and therefore half of the brightness of this particular fixture. So if I'm programming this job and I want to make it so that the brightness is maintained as I shift from warm to cool, instead of kind of bringing them both up all the way to maximum capacity when I want them both on together of neutral value, I need to instead bring them all the way down so that they're about 50%. So that basically looks in the programming side a little bit like this, right? So one kind of goes all the way up, and then the other one, and they only meet in the middle. And then that allows you to have a constant and even brightness all the way through. So now we've reconfigured the same fixture, this Nanotech 1x1, with the DM10X, and instead of having a DMX signal coming to it, we're using these two little POTS dimmers to mimic a 0 to 10 volt signal. So one of these guys is going to dim the fixture up and down, and then the other one is going to shift it from cool to warm. So while we do this, let's come and take a quick look at the little multimeter here. And if we kind of get to a point where you can see both the fixture and the meter, as I shift it from warm to cool, Now, instead of seeing that change in power output from having both channels coming on, we're seeing that the wattage is maintained all the way across the spectrum. So in addition to the obvious here, there's some significant considerations to be made. From a power perspective, the DM10X device is throttling the overall wattage of the fixture when both channels are on full, so that the power can be maintained all the way across. In DMX fashion, it needs to be managed by somebody else, or us if we're doing the programming. Number two, when choosing the LED chips, it's important to choose two that, when mixed together with a 50-50 blend, are going to give you the most common CCT used on the project. This way, you get to maximize the output for both and stop you from straying too far off the blackbody curve. And that was the answer to today's question of how a tunable fixture works. If you have a question you'd like answered in plain English, please reach out to us via Instagram at NanoLTG, or you can email us at info@nanoltg.com. Cheers.
Ask Nanometer.